Okay, 2.3. 2.3. It is getting informations from the graph of the function. So after this section, we can, like after this section, we can.
So she hasn't been paying us.
Okay, after this section, we can, if we see any graph, we can get all the information from the graph. So last time I start by example, and we finished the example for the first part of this section. The first part of this section was talking about the values of function. The values of functions. And today we're going, and it's the domain, and its domain and range. So last time I was starting by giving an example, and we did all the part of the example, but I left this part, the domain and the range. Okay, let me start talking about the domain. So the domain here, domain, and range from a graph. From graph. So last time we talked about the domain. Who will remind you what is the meaning of domain? In chapter 1 of this, in the chapter 1 of the equation, what is the domain? What is the domain of equation or domain in general?
All possible values for the input?
Yes, exactly. All possible value for the input. And the range is the all possible output of the function. But let me today give you an like formal definition of the domain. So the domain, this is the formal definition. So the domain of the function so the domain and range of function y equal f of x can be obtained from a graph of f as showing in the graph below. I will show you in the graph below how we can find the domain and the range from the graph. Last time we learned how to find the domain without a graph by checking which possible input we can put inside the function that makes the function defined. But today we're going to learn that by the graph. By looking at the graph, we can know this is the domain and this is the range. So let me show you more how we can find the domain. So here I have, this is my x-axis, my y-axis, sorry, and this is my x-axis.
Professor, excuse me for interrupting. Was there a sign-in sheet for today?
Yes, it is in the link of the chat. Again, this is the end. Here is. Okay, so I have this picture, this is graph. Here, this is my y-axis. This is my y-axis, and this is my x-axis. And the graph look like this. Something like that. So from the graph, after today, we can know what is the domain and what is the range by taking all the x values. We look into the all x values such that for the f that make the function f defined. So if my function looks like this, if my function from this point ending at this point, so all the possible x values from here until this value, from here x1 to x2, this is my domain for the function. So the domain has closed interval from x1 until x2. So from this value until this value, this is my domain. Again, how I know? Just I take all possible value for x that make the function define. Okay. And for the range, the same things. I take all corresponding y value for all x values. So this is the corresponding value for the x value here. This is my y1, and this is my y2. So the range here, the range is the close value from y1 up to y2. Okay, so this is my range. It's clear how to find the domain and the range from the graph?
Yes.
Okay. Let me give you more example for that. So the example now, example, find the domain yeah, can you please go back? Yes. So can you, like, I wanna specify the domain here. The domain is all x values which the function define, which f is the function is defined. The range, all the corresponding values to this x values. the range is all corresponding corresponding y values. Y values. Okay. So find the domain and range from the graph below. So my graph looks like this. My graph is like this. But hold on, like have to, what is this? It's like semicircle, half of circle. There's only the top of the half circle. Okay, so the question now, and this circle has a radius. The circle has a radius like 2. We have 2, we have -2, and here we have 2. So the question is, find the domain and the range from the graph below. Who will give me the domain and the range of this graph? What is the all set of x values that makes the function define here? I get answer here from -2 to 2. Is open, it's open interval or a closed interval?
No.
Closed,
Because we including
yes.
those values.
Yes, it is closed. Nice, exactly. So the values starting from -2, okay? And look, all these values, it's define the function. The function is f here. The function is f. So the function here is f. All the values for x that are used for defining the function f, they are all from -2 to 2. Why? Because -2, it has a value is 0. 2, it has a value is 0. And every value here, it has a y value, okay? Every value, every x value has a y value. For example, if I take here the 0, it has a value 2, okay? It has a value here 2. This is mean all this value are the input for this function. So the function, the domain here, the domain is a closed interval -2 to 2. what is the range? What is the range for this function?
0,2, including both values.
Yeah, it's closed or open, Angel?
Close.
Closed. So look, all the values here for the y. Oh, sorry. So all values here are used as a y values starting from the 0, because the 0, it has a value. It's at -2, it has a 0. At 2, it is a 0. So, and another value, like for example, the 0, the x value 0, it has a value 2. So all these values for the y-axis are used. This is mean if it is used, this is my range. So actually I'm looking for the values are used in the x-axis. So this is my domain. I'm looking for the values are used in the y-axis. So this is my range, okay? So the range is a closed interval from 0 to 2. Any question? How to find the domain and the range from the graph? So now any graph, I can find the domain and the range for any function graph by looking to the function graph, by looking to the graph itself. Okay. Now let's go to the second part of this section. So now this part is talking about solving equation. And inequality graphs. So now we will learn how to solve equation and inequality from the graphs itself. Can you go, please? Yes, sure. So this is my y-axis, and here is my x-axis. Okay. So now from any equation in the graph of function, I can solve equations, and I can solve inequality. So let me give you the definition how we can solve the equation from the graphs and how we can solve the inequality from the graphs. So how we can find the solution for the graph? By using this definition. What is the definition said? It says that the solutions of the equation f of x equal g of x are the values of x where the graph of f and g are intersect. I will show you that how is we can find the solution between two graph functions. The second definition for how we can solve the inequality by this definition, it says the solutions, the same things like equation of the inequality f of x less than g of x are the values of x where the graph of g is higher than the graph of f. Okay, let me now explain what is that said. What is this saying? Okay, so I'm going to graph two functions in the coordinate plane. This is the first graph, and this is the second graph here. So first coordinate plane, second coordinate plane. The first graph is a function like this. Everyone hear me? Clear?
Yes.
Yeah, sorry for that. The connection is bad today. Okay. Okay, so if I have two graphs, let me rewrite again the definition. So the first definition says here, so I have and this is the second one. Okay. So the first function this is my y-axis.
Yeah, I can hear you.
Is good?
It is now, yeah.
Okay. So, okay. So if I have a function, the first function look like this. Yeah, okay. Like that, the blue color, like that. And the same things, my first function, second function is the blue color. And the first function like this. This is called F. The blue one called G. So the F, the red one, it's a function, has a graph look like this. And the G has a graph, is a function with a graph like this. Same things for the other coordinate plane. The question is now, what is the solution of the equation f of x equal g of x? So to find the solution of the function f of x equal g of x, we look into the value x where the graphs of f and g are intersect. So what is the graph f and g are intersect? The both graphs are intersect at 2 points. This is the first point, and this is my second point. So the intersect between these two functions are the solution for the equation f equal g. Makes sense? Clear? So if the question asks, what is the solution of the function of x equal g of x, it's the intersect between two functions, and we look into the x values. So this is the first x value here. Usually, we're looking for the intersect. This is the first intersect, and this is the second intersect. And we look into the x value. This is x1, and this is my x2. Make sense? So here, the solution of the function f of x equal the function g of x are x1 and x2. So now from the graph, we can know what is the solution for two functions are equal. We're looking for the intersect for these two functions, the value x of the intersect. Any question for the first point? Any question for this one? How to find the solution of two equal functions? Okay, for the second one, the solution of inequality. So if I have inequality, and the question is asking about the solutions of the inequality when the function f of x less than the other function g of x, or the value of x where the graph of g is higher than the graph of f. So here we have two functions. This is the first function, and this is my second function, the g. And the question is, what is the solution for f of x less than g of x? What is the value? What is the solution of the inequality when the f of x is less than the g of x? So in the beginning, I'm going to make it easier. So what I'm going to do to get the idea, then we solve more harder. I'm going to change the function, the graph of this function, as something like that. I make the g look like this. This is my g function. And my f function, I make it like this. Okay. So this is my f, and the blue is the g. So now the question is find the solutions. Find the solution of the inequality f of x less than g of x. To find the solution for this inequality, we're looking for the x values such that the graph g is above of the graph f. So we're going to the graph. The graph g here is above of the graph f from this point, because here, for starting from this point here from the infinity, I said the blue one is down of the red one. This is not the solution for the inequality. When the graph G is higher than or it's above of the graph F, at this point it looks like it's above of the red one. The blue curve here in this point, starting from this point, it's above of the red curve. This is mean from this point with actually has x value here, which actually has x value x1. This is my x1. From this point, I see all this value is above of the function f. This is my x2. From this value, I see all the blue curve, it's in the top or above the red curve. This is my solution for this inequality starting from x1 up to x2. So the solution of f of x less than g of x, it's starting from this point, but this point is not including because this point that make both of the function are equal. So we exclude it, x1, comma, x2. Makes sense? How to find the solution for the function f of x less than g of x? Any question how to find the solution for inequality and equations from the graph? Okay, let's now give you example. So my example is, if I have a curve like this, xy or xy plane. So my first curve has a graph like this. It is x squared. This is my first function f of x equal x squared. Let me move it a little bit. So here, f of x equal x squared. And my second function, it is the blue one. The blue one is, I call it g of x equal x plus 2. This point here is minus 2. Sorry, this is here. It's minus 1. And here is 2. Okay, here x squared. So my question now, first one, look for f of x equal g of x. Second one, find solution of f of x less than g of x. Third one, find the solutions of f of x less than or equal g of x. And fourth one, find the values, the solutions, of f of x is greater than g of x. Who will do the first one? Who will do the first one?
First one's -1 and 2, right?
Yes, exactly. Can you explain why?
Those are the 2 points when the graphs intersect, which means they're equal at those points. So f of x equals g of x.
Okay. So we look into the two graphs. The first graph is f of x, the red one, and the second graph is the blue one. For the first one, they're asking for when this function f of x equal g of x, or they ask for the solution for the f of x equal g of x. Like from the before, the solution of the equation when these two equations are equal, we look into the x values where the graph of f are intersect the graph of g. So we're going back here. The graph, the first graph, the red one, intersect the second graph at x value equal -1 at this point. And the second point, this one, it's at x equal 2. So the solution for the first one is -1, x equal -1, and x equal 2. So the first one here, x equal 1, this is the first solution, and x equal 2. Who will do the second one? Find the solution of the function f of x less than g of x. Let me remind you from the definition. The solution of the inequality f of x less than g of x are the values of x where the graph of g is higher than the graph of f. So we're looking for the graph of g where in the graph in the xy coordinate the function g of x is above of the function f of x. So here they ask when this in the graph the function g of x is above of the function f of x. Who will do this first? This one?
I try.
Yes, you can try.
So which f of s is less than g of s, it will be from -1 to 2.
-1 to 2, right? This is true. We look into the two graphs. They ask me when this graph, this function is greater than the other function. So we go back to the graphs. We're looking for the graphs g of x. We're looking for the points. Where is the point such that the function g of x is above of the other function f of x. So if we look into this point here, starting from this point, I see the values for f of x is greater than the other function g of x. So this here is not my points I'm looking for. But if we keep moving at the x axis until this point, I see at this point x equal -1, I see the function g of x are equal to the function f of x. But here they ask me when this function g of x is above of the function f of x. So if I keep moving for the point -1, like for example, this point, this point, this point, this point, I see the blue curve. Look, the blue curve is above of the red curve. So this is my set of the solution. I'm looking where is the blue curve is above of the red curve, starting from this point until this point. All these values, the blue curve is above of the red curve. But here we have to make sure there is no equal. So what is the solution, Angel? Here we don't have equal.
We include parentheses, -1, 2, parentheses.
Yeah. So we have to make it open parentheses. What about this one? Who will do the third one? Here we have equal. The difference between 2 and 3, here less than only, but here we have less than and equal. When we see equal, this means f of x equal g of x at this point and at this point, and also the interval between these 2 points, because the function g is above of the function f. The function, the blue color curve is above of the red color curve. So this is mean the closed interval here from -1 to 2. Who will do the last one? Who will do the fourth one? Even if it's wrong, try to solve it, or try to give me a solution to give you how the idea how to think about this questions. I mean, anyone here want to try how to do the last one? When the function, find the solution when the function f of g is greater than g of x. Or in the other word, when the function f of x is above of the function g of x. When, at which point, the function f of x is above of the second function g of x. Anyone who want to solve this solution, this question? Any idea?
From negative infinite to a -1, and from 2 to positive infinite.
Nice. This is a nice solution. Okay, let me explain how he think about this one. Jim, this is true, right? This is right too. So the question is, find the solution of f of x is greater than g of x. And on the other word, the question is, when this function f of x is above of the function g of x, or higher than the function g of x. So I know the function f of x is the red color, and I know the function g of x is the blue color. So I'm looking for when the function f of x, the red color here, this function is above of the function g of x, or in the top of the function g of x. So if we are looking for the point starting from here, I say all this point here, the function, all this point here, the x values here, the function f of x is higher than the function, the blue color, g of x, until this point. And after this point, starting from this point, I see all the blue curve is higher than the red curve, and this is not my solution. And I keep moving until the point 2. After the point 2, I see all the red curve here is higher than the blue curve here. So my solution is from negative infinity, from this point, until this point, -1, and open parentheses at -1. Why? Because we don't have equal. There is no equal. Union means and. This is mean and, okay? If you first time you see this symbols, this is mean union. Union means and. And from 2 to infinity. But again, the 2 is not inside the interval. Why? Because we don't have equal. So this is the solution from -infinity to 1 and from 2 to infinity. Any question about this example? Here, I'm going to change the word, find the solution. The solution for f of x equal g of x. Okay, any question for this example? Any question for this one? It's clear how to think about this one? Okay. Now let's go to the new section, is increasing and decreasing function. Increasing and decreasing functions. So now we're going to learn when the function is increasing and when the function is decreasing. Okay. Let me give you the definition for increasing and decreasing. After that, I'm going to do the same things, explain what is the definition said. Okay, the same idea like before. So here, okay. So here the function f is increasing on the interval I. If I have interval I, if f of x1 less than f of x2, whenever x1 is less than x2. So here x1, x2, f of x1 less than f of x2, and the interval I. Same things for decreasing. F of x1 is greater than f of x2 whenever x1 is less than f of x2 in the interval. Okay, I'll explain that by graph. I'm going to graph a two coordinate plane. One of the coordinates for increasing and one of the other for decreasing. So the curve, the first curve look like this. It's like that here. And the second curve like this. This is my x-axis. X-axis. Here the y-axis. This is my y-axis. So what does that mean? First of all, this is increasing function and this is decreasing function. But let me apply the definition. So this is my x1, for example. I put this one as x1. This is my x1 here. Here's my x1. And this point is my x2. So why this is increasing? The definition says x1 is less than x2. x1 is less than x2. The value for x1 here is less than the value for x2. And also the f of x1, it is here. This is my value f of x1. Here's f of x1. And also here the f of x2. It is here. F of x2. F of x2 is greater than f of x1. Here is 5, for example. Here is 1. Here is 6. Here is 2. F of x2 is greater than f of x1 whenever x1 is less than x2. Also the same things, x2 is greater than x1. So x2 is greater than x1. F of x2 is greater than f x1. So the curve is increasing. So here the function f is increasing. We don't have to apply the definition for each, like for each graph. Just look to the graph. If the function, the graph look like it's increasing from the left to the right, if I go from the left side here to the right, like this, I see the function is increasing. The same things here. If I go from the left to the right, the points, I see the function is decreasing. The value for f is decreasing. Same idea. This is my x1. This is my x2. x1 has a value. It's f of x1. Let me take another value here. So this is my x1. This is my x2. x1 has a value here, is f of x1. F of x2 has a value, f of x2. F of x1, look, is greater than f of x2. But x1 is less than x2. That's why the function is decreasing. Logic. Again, f of x1, if we look into the picture here, the graph, has a value is greater than f of x2. But x1 is less than x2. That's why the function is decreasing. Okay? Let me give you example. And from the example, you will know how to find the increasing and decreasing point curve. So my example, here's example. It's look like this. I have a curve. So the graph like this. This is A, B, C, D, F, G, H. Let me make a simple graph in the beginning to get the idea, then I will make it more harder. So the graph looks like this. A, B, C, D, F is G. This is my A, sorry. So the question is, find the interval. So the question here, find the interval on which f is increasing and on which f is decreasing. So this is my, again, here is A, this is B here. A, here's B, C, D, E, F, G. Okay. The question is, find the interval such that on which f is increasing and in which f is decreasing. Who will give me the interval for which this function f of x is increasing and for which this function is decreasing? So for something like that, we have to split this curve like until pieces. So this is my first piece here.
From A to C is increasing.
Okay. From A to C is increasing.
From E to...
From A to C is increasing.
C to E is decreasing.
And what you said again?
C to E, Charlie to epsilon is increasing. Excuse me. Yeah.
Decreasing.
Decreasing, excuse me. Yeah.
Okay. Okay. And then the function, look, from E to G is increasing again. So the function has two intervals for increasing. If we look into the function from this point going up to this point, this means the function, if we're going from the left, like I said, to the right, the value is increasing. Then if I want to continue in this function from this point going down, this means the function is decreasing from this point to this point. And if I want to look into the function again, from this point here, from E, it goes up again, up to this point is G. This means the function is increasing, decreasing, increasing again. So the interval that the function f of x is increasing is from this point, it's A, up to C. A comma C. And also is increasing on the interval this from E up to G.
So you're including the vertexes like C and E?
No, exactly. It's not including. Nice.
Okay, no worries.
Yeah, thank you.
No, I was just confused.
So the point, yeah. So the point is not including. For increasing, the point must be disclude from A to C, here open parentheses. Why? Because at C, I can set is increasing and also I can set decreasing. So I exclude this point. And also increasing at the point E, open parentheses, to the G, open parentheses. So for all increasing and decreasing, you have to put it as open parentheses, as open interval. And for the decreasing, the function f, the function
is
f of x.
Let's see, where's the link?
Yes, is decreasing. The function is decreasing from this point, from C, going down up to E. On open interval, C up to E. Okay? Any question about this one? So here the increasing, here is decreasing. Any question how to find the increasing and decreasing on the by using the graph? So yeah, so the increasing, we look into the graph from the left up to the right. If the function look like increasing, it will be like the open interval from the x1 up to x2. Same things for decreasing. It's clear how to find the increasing and decreasing interval by looking to the graph. Okay, if it's clear, let's go now to the local minimum and local maximum values of the function. So here, after we're looking, let me just remind you what we did. So in this section, we find the solution when the two functions are equal and the solution for the inequality by looking to the intersect. If we're looking for the equal, we look into the curve when the curve is higher or down of the other curve to find for the solution for inequality. For the equation, we're looking for the intersect only. Second part of this section, we find the increasing and decreasing interval by looking to the graph. Now, the last part of this section, we have to look for the maximum and minimum value by looking to the graph too. So, local maximum point and minimum points. Values of the function. Okay. So what is the mean of the maximum and minimum value? I will explain that by the graph here in the below. So if I have curve, the curve look like this. It goes up like that, then goes down like that, then goes up again. No, it's not nice. Again, up, down, and up, and down, and continue down. The function when it change from increasing, look, we learned before how is the function increasing. The increasing function is from here up to here. Then the function look like decreasing up to here, then increasing again up to here, then decreasing. This point on the top for the function are changing from increasing to decreasing. This point here, it's called maximum value. The maximum value, it's the values where the function it change its value from maximum to minimum. And the minimum value, it's here, it's the value where the function is changed from decreasing to increasing. Makes sense? So this value here is called the local maximum point. Local point. And the same things here. Local maximum point. But this point here in the bottom, it is local minimum point. So now from the graph, I can know where is the maximum and where is the minimum points, the local maximum and the local minimum points. Okay. Okay. Let me give you an example how to find the maximum and minimum. It makes sense how to find the local here from the graph. Is it clear? Again, this is my x-axis, and this is my y-axis, and this is my x-axis. So example here. If I have Cartesian plane like this, and the graph is like that, the question here, find, so the example here, the question is, find the increasing and decreasing interval for the function f Okay. And the second, find the maximum, local maximum value, max, and local minimum value for function f. By the way, here is A, B, C, D, F, G, H, I, H, I, J. Here I, small I, and here is J. Okay, who will do the first one? Who will do the first question? Find the increasing and decreasing value. Oh, okay. A, B, C, D, E, F, G, H, I. Okay. So A, B, C, D,
May I try?
E, F. Yeah, you can. But give me 1 second. E, F, G, E, H, I. Yes. What is the increasing and decreasing interval for the function f?
So first we'll be increasing from C to E. That's one increasing value.
Okay. From the beginning, what you said?
From A to C is decreasing.
Okay.
From C to E is increasing.
Okay.
From E to G is decreasing.
Perfect.
And from G to I is increasing.
Increasing. Nice. So the function again, he said, from this here is decreasing. Stop up to here. Then the function is increasing from here up to this point. Then the function is decreasing again using the same color. Is decreasing again. Then is increasing again. So the interval for the first one here, for the first one, increasing on the open interval from this point C up to E, C, comma E, and also from this point G up to I, G, comma I. The function is decreasing from this point A up to C, and also decreasing from E up to G, E, comma G. Makes sense for the first one? Here's E here. Justin, what's your question? E, H, I. So from A, from this point up to C, onto this point is decreasing, then increasing from C to E, then from E to G is decreasing, and from G to I is increasing. Okay. Now for the second one, who will do the second one? Find the local max and local minimum values. What is the local minimum values here? What is the local minimum?
The local maximum will be E,
The local
and the
minimum.
local minimum will be C.
Okay, so he said, Angel, at this point, C, it's a local minimum. This is true because the function is changing from decreasing to increasing. This is mean this point at x equals C has a local minimum. The function is changing from increasing to decreasing at this point E here has a local maximum. And the same things at G, changing from decreasing to increasing, so it has a local minimum. So for the second one here, number 2, at x equals C, this point, and this point, and this point, at x equals C has a local minimum, and also at x equal G has a local minimum. So at C and G, x equals C, and at x equal G, the function has local minimum. At x equal, and the top here, E, so at x equal E has a local maximum. At x equal E, the function has a local maximum point. Okay, any questions so far? Is it clear? Anyone has a question? Okay, so we finished this section, 2.3. Let's go over 2.4. So in 2.4, we have only 2 formula we have to know during this section, and where I will give you example for these 2 formulas. So you have to know just only 2 formulas in this section: the average rate of change of function. Okay, so the first formula we have to know in this section is the net change. So suppose I have a function, and this function, so let me have a function. This function is called f of x, y equal f of x. So the net change of the function f between x equal a and the point x equal b is given by as net change, same like before. We use this in the first section of this chapter. So the net change is given by the formula f of b minus f of a. This is the net change formula. So this is the first formula we have to know. Net change formula. Second formula we have to know is the average. And the average rate of change of the same function f of x between x equal a and x equal b is given as here the net change, the average rate of change equal the net change over b minus a, or in the other word, it is f of b minus f of a, because the net change formula is f of b minus f of a over b minus a. Is it clear, the formula? Okay, is it clear? Just we have to use this two formula during this section. The average rate of change is f of b minus f of a over b minus a. The net change equal f of b minus f of a. Okay?
So it's just like determining the slope between 2 points, basically?
Exactly. It's look like a slope. It's a look like a slope, exactly. It's look like slope of the curve. This is the formula of a slope, but for line, I mean, for line. But there is no slope for curve. Understand? There is no slope for curve. The slope only for line. But we're going to use this formula, the average rate of change, for any function. This is mean for line, for parabola, for any function, we're going to use this. This function, average rate of change, it's look like the slope of line, but it's not actually the slope of line for parabola, because the parabola doesn't have a slope. The line only has a slope. Let me give you example for that. Any question before we go over example? You only have to know this two formula for all 2.4. So the example now. I have a function f of x equal x minus 3 square. The question is, find the net change and average rate of change. So the question now, number one, find both of the net change and the average rate of change between the points A, 3 and 1, B, between 7 and 4. Who will do the first one? The net change, I need the net change, and I need the average rate.
May I try?
Yes.
So first we should do for 3 in the s minus 3 square.
So
That
what's
would
the
be
formula?
0.
Angel, what's the formula for net change?
I change
What is-
f of s2 minus s.
Yeah, this is my x. So actually I start from the smaller, hold on. So here, this is my 1 and 4, 1 and 3, because in general you start from the smaller, but doesn't matter 1 and 3. Doesn't matter from where you start, but I prefer to start from the small up to large. So here 4 and 7. So find the net change for the first one. This is my x. So what is the x, my x1? And what is x2? It doesn't matter what
2
is
will be 3 and f1 will be 1.
So f of 3 minus f of 1. So Angel, actually he used 3. He used this as x2 and this is as x1. Doesn't matter if I want to start from here minus this one or this one minus this one. But I prefer to start from the large, from x2 up to x1. So what's the, okay, plug the 3 inside the formula. What do you get, Angel?
0.
0. Because 3 minus 3 is 0, square is 0. Continue.
4.
1 minus 3 is 2, square is 4. So what's the answer?
Negative 4.
Negative 4. Now, the average rate of change, average rate of change is?
Negative 4 divided by 3. Wait, divided by 3 minus 1.
Nice. So net change over x2 minus x1. So negative 4 over 3 minus 1, get negative 4 over 2. What's the answer? Negative 2.
Negative 2.
Okay, perfect. Here, ARC means, sorry. So A means the average rate of change, okay? Who will do the second one for B? Who will do the second one, 4 and 7? So for the second one, net change I get answer here 15. How you found it? So again, he used this as x2 and this is as x1. So f of x2, f of 7 minus f of 4. Plug the 7 inside the formula. So I get 7 minus 3 square, 4. 4 square is 16. Minus, plug the 4 inside the formula. I get 4 minus 3 is 1. Square is 1. So we get 15. This is true. And what is the average rate of change? Average rate of change. It is 5. Okay. So he said the net change over x2 minus x1. So the net change is 15 divided by 7 minus 4. 7 minus 4. I get 15 over 7 minus 4 is 3. So 15 over 3 is 5. This is true. Thank you. Any question for this two example? Any question for this two example? Okay, if there is no question, we're going to stop up to here for today. Okay? See you next week. Thank you.